NEB TV, what's trending in science. Welcome to NEB TV. Today, I'm joined by Danielle Friedman, one of our product marketing managers. Hey, Danielle.
Hey, Dina.
And we are talking about sustainability. First, in our Science in 60 segment, Danielle is going to tell us about the development of our new Monarch nucleic acid purification kits. Then, we will interview Josh Resnikoff, who's the editor of Lab Conscious. Then we'll take a trip down to Harvard University to speak to the Office of Sustainability to hear some initiatives that they have going on there. And lastly, we will take a tour of the Wastewater Treatment facility here on the NEB campus. Are you ready?
I'm ready. Let's go. One of NEB's founding principles is to develop state-of-the-art molecular biology reagents while being mindful of their environmental impact. This philosophy drove many aspects of product design when we developed our new Monarch nucleic acid purification kits. Obviously, product performance was critical, but whenever possible, we tried our best to minimize the impact on the environment. We were able to reduce the total plastic used in our kits by an average of 34% when compared to the market leader. We did this by custom designing thinner-walled columns and collection tubes while still maintaining maximal performance and durability. We also selected bottles that were lighter weight and were appropriately sized for the amount of buffer that they stored. Overall, we estimate that these small changes can add up to over 140 tons of plastic saved each year if everybody switched to Monarch. Additionally, our kit boxes are made from 100% post-consumer material, and we designed them to be sturdy and reusable. Actually, all of the materials in our kits are recyclable, and we provide detailed instructions in the box on how to recycle every component.
Lab Conscious is an online community of researchers committed to reducing the environmental footprint of bench science. There's a lot of really good information out there, as on the university level in particular, for ways to green your lab, but there wasn't sort of an online standard for how those things were accessed. So we've tried to start compiling those so that there's a one-stop shop resource for people. We're really trying to carry that message home into the labs so that everyday things like turning off the lights, shutting the sash, just recycling in general can really be met by any customer anywhere to help decrease the overall footprint of research science. The easiest way to sign up is to join our mailing list. Really just become part of the community, contribute on your own. Anything you see that you want to change, make a change locally. Turn off the lights, shut the sash, and recycle your cardboard.
Hi, I'm Quentin Gilly, and I'm the Senior Coordinator at the Harvard Office for Sustainability. And my role here is to make our labs as energy efficient as possible. We also have a holistic plan that also focuses on our culture and learning and educating our researchers and students on how to make a safe, sustainable community. One of our main areas of focus with our Green Labs program is to look at plug load. And one of our biggest plug load users on campus is our ultra low temperature freezers, or -80 freezers. We have several opportunities to improve the efficiency of our freezers. Number one is to get more energy efficient freezers in our labs. The way we do that is to provide an incentive to purchase the most energy efficient freezers possible. We also provide free preventative maintenance plans for our freezers. This includes filter changes and inspections and the information is given back to the labs so that they can make repairs if necessary. And this helps improve the longevity of the equipment, but also improves the energy efficiency. So one of the main things you can do in your lab when you're designing and planning it out is to consolidate your ultra low temperature -80 freezers into one single area. And by doing this, you can use a dedicated air handler to capture all the rejected heat that comes out of those freezers and exhaust it out of the building. This is a much better strategy than scattering your freezers around the lab or putting them in a hallway, because when you do that, the heat is not captured directly from a source, and it causes extra drain on the heating, ventilation, and air conditioning systems. One of our most successful occupant engagement programs at Harvard University for reducing greenhouse gas emissions is our Shut the Sash competition for chemical fume hoods. We have 34 labs involved in the competition, and it's a monthly competition so that each lab has a specific goal to reduce their greenhouse gas emissions. These displays indicate the amount of air in cubic feet per minute exhausted out of this lab. So each lab has this to refer to, and then they have their monthly results. So each lab has a specific goal based on the number of fume hoods and the type of research that they do. So for this lab, for example, they came in under their numbers over the course of the month and they achieved their goal. That means that they get invited to special parties and events at the expense of the Office for Sustainability to celebrate their success in the program. If you're interested in finding out more information about lab sustainability, check out mygreenlab.com, and you can also check out the Labs 21 wiki. And lastly, please check out my website, green.harvard.edu/labs.
I'm here with Barry Cohen, who's the Manager of Environmental Health and Safety here at NEB. Hey, Barry.
Hi, Dina. Welcome to the greenhouse.
Thank you. And we are in the Wastewater Treatment Facility, which treats NEB's campus's wastewater. Barry, will you take us around and show us how it works?
I'd be happy to.
Great.
So we're standing here inside what we call the greenhouse. This is a very unique and complex wastewater treatment plant where we take all of our wastewater, whether it's from the laboratory, the kitchen, restrooms, all the sinks in the different buildings, and it all gets processed through a series of physical and biological filters before it's ultimately discharged from the facility and actually goes back into the groundwater. So from a sustainability standpoint, where most companies will take their water and send it to a municipal wastewater treatment plant, it gets processed and then it gets dumped into a river or the ocean, we're actually recycling or reusing almost 100% of the water that we take from the town. You won't see something like this in a life sciences building. So behind me, out through the glass here, there are a series of tanks in the ground, and this is the first zone of the process. This is where all the waste is combined into what we call the blending tanks. So all of the different types of waste will get mixed up into a homogeneous mixture, and then from there, it'll move on to the aerifying and clarifying tanks. There are 6 sets of 4 tanks each. We call them trains. And the purpose of the clarifying tanks is to continue to mix up all the material that's in there, but it also adds oxygen to the process. And the oxygen actually feeds the bacteria that's in there so that the good bacteria will compete with the bad bacteria and kill off the bad bacteria. And it's constantly moving, and from here, all the material will move over to what we call settling tanks. So as the material moves from the clarifiers into the settling tank, all of the solids will settle to the bottom and push the clear water up to the top. And then from there, through a series of pipes, the water will end up in the sand filters. We're now standing in the marsh, but unlike other marshes, all the water is down below the surface. Like the sand filters, the purpose of the marsh is to further treat the wastewater and to filter out all of the solids. And then from here, the liquid, mostly clarified now, will move to the final step in the process, which is the ultraviolet light. Once the water leaves the marsh, it gets collected into a sump pit, and from the sump pit, it will get pumped through a trough, which is actually behind us here, that has a series of ultraviolet lights. And if there's any bacteria left in the water, they are very sensitive to ultraviolet light. It'll kill off the bacteria, and then from there, the water is pumped out into our leaching field, which is in another part of the campus.
So Barry, thanks for showing us around today.
My pleasure.
Great. So Danielle, thanks for joining us today.
Thanks for having me.
And thank you for watching. If you have any suggestions for future episodes, please let us know.